Science and technology. Research is today more active than ever and produces more results than ever at both levels, fundamental and applied science. Fundamental science opens up new fields for fascinating applications in domains like genomics, high-energy physics, non-Euclidean geometries, just to name a few. The path is long indeed, but on the long run, it will create new territories for innovation. And applied science also produces amazing results. Think about an invisibility cape, exactly like the one in Harry Potter. It already exists in labs. The boom of nanotechnologies created nanorobots, artificial muscles with carbon nanotubes. Helmet converting brainwave into instructions for a machine. Bioengineering now makes it possible to connect sensors to nerves. And today, recent progresses in artificial intelligence allow computers to learn exactly like the human brain by observing and connecting facts. Opportunities coming from science, raw technologies out of the lab are extremely numerous and large. However, it's important to realize that the path between lab science and startups is always very long and chaotic. Artificial intelligence, for example, started in the 50s and remained a small experimental niche for a long time. But now, with machine learning and deep learning, it is in the process of revolutionizing a large number of different domains. But it took over 60 years to reach that level. And in this long and chaotic process, persistence and serendipity play a key role. Serendipity, that we already introduced, is about the random exposure to unexpected outcomes. For example, the use of femtosecond lasers for eye surgery was discovered by accident, when a lab researcher actually hurt himself doing experimentations on lasers. The doctor who examined the wound was amazed by how clean it was, and both ended up teaming in building a startup for developing laser machines for eye surgery. Serendipity does, and will always play a key role because in many cases, the real application of a lab results is very far from the initial ideas for which the research was initially conducted. Let's remember that transistors, the core component of the entire information technology industry, were never designed for computers, but as power amplifiers to replace vacuum tubes on telecommunication networks. Aspartame, the sweetener, was discovered by SEAL Labs doing research on ulcer. The researcher discovered, by mistake, its amazing sweetening power by licking his finger, having touched a piece of paper where it was spread. Not a very wise move for a researcher, but it led to discovering a billion-dollar product. Viagra was developed initially as a blood pressure molecule. It is only at late stages in the FDA approval process that Pfizer observed that some patients were not returning the pills that they hadn't used. When trying to understand that, Pfizer realized that these patients were not returning the pills were always over middle age and male, which led them to realize that this molecule had a very unexpected secondary effect. This brings us back to the ability to capture weak signals we already talked about. And along with serendipity, persistence is also key because a technology breakthrough will always follow an S-curve that suggests that when it comes out of the market, its performance will be bad, much worse than existing options. So the talent of the entrepreneur will then be to sense the long-term potential beyond short-term limited applications. For 20 years, all that could be done with LCDs were simple displays for watches or scientific instruments. Believe me, very few TV manufacturers saw in the LCD field the technology that would actually one day challenge their entire business. And yet this is what happened, because LCD technologies improved up to the point they replace CRT displays almost everywhere.